Hi everyone, let's solve this problem. Merge triplets to form target triplet. A triplet is an array of 3 integers. So every triplet has 3 integers. You are given a 2D integer array of triplets where triplets of I has 3 elements in an array. Describes ith triplet. You are also given an integer array target with a triplet xyz that describes the triplet you want to obtain. To obtain target, you may apply the following operation on triplets any number of times, possibly 0. Choose two indices, 0 index I and j, I not equal to j. That means let's say for example I am selecting 0th position of any two triplets in the given 2D integer array and update triplets of j to become maximum of ai comma aj comma max of bi comma bj and max of ci comma cj. So basically we are if we take these two triplets, we are going to take max at every position. 1 and 2 will be maximum, 5 and 8 will be maximum, 3 and 4 will be maximum. That's the operation they are kind of doing it. That's it, nothing major in this case. And whenever you do such operation on any of the two triplets, if you in this case if you do the max operation on first and third triplet, you are getting the answer 275. So you can do any number of times, either 0 times as well. So now we are going to solve this problem in a different approach. The approach is that, let's say for example, if any of the triplets, let's say for example this particular triplet has a value I have 7 at second position but 8 at the second position in one of the triplets. Like I can never take this triplet no matter what, right? This is not even possible for me to take this particular triplet because there is a number which is greater than this. So even if I do max of operation with this triplet with any other triplet, this triplet is useless. So if you find any triplet and in any triplet, if you find any position like 0, 1 or 2 which has numbers greater than the target triplet is also given, then you are going to actually ignore that. When you ignore the triplet, we have just two triplets, and when you are kind of iterating over this triplet, you know that first initially I am iterating over this particular triplet and 2 is present at 0th position, this is also present, so I will add my 0th index, that is already covered. 5 is present at first index and 7 is present at first index, so these are not matching, but it's fine. 3 is present at second index and 5 is present at second index, that is also not matching, it is fine. Now 1 and 2 are not matching, so I'm not going to do anything. 7 and 7 are matching, so I'm going to insert the index 1, and then 5 and 5 are matching, so I'm going to also include the 2 index. So in this case it has 3 indices, length of this is a set, so it will always contain the unique elements. So the set size of the set is 3. That means if it is 3, that means there is a triplet which exactly has the same operation, same values as the target triplet. Let's take one more example. So if you see 3 and 4, this particular triplet has a value greater than this particular value in this target triplet, so we are going to ignore this particular triplet and there is only single triplet now. Now if I am iterating over this particular triplet, 3 and 3 are matching but 4 and 2 are not matching. So in this case the set will be 0 comma 2 because last elements are also matching, but the size is still 2, so the answer is never going to be 3. The size of the set is never going to be 3, because of which we will never be able to get a triplet combination where it can match the target element. So let's try to code this up. So basically we are going to iterate over triplets and if current of 0 is current of 0 is greater than target of 0, that means for like the 0th index, or this same thing is applicable for all the indices 1 and 2 as well. So in this case, what we are going to do, we are just going to continue, we are not going to consider this triplet. If this is not the case, we know that we have 3 elements in the triplet, that is nothing but 0 to 3. We are going to iterate over all the elements, and if any particular element in the current triplet is equal to the target triplet, then we also have to declare our set, let's say indices set. We are going to add indices dot add of current index. So once this particular index is added, towards the end of it, we are going to check if indices dot size equal to 3. If it is equal to 3, that means it has all the elements which are equal to target, otherwise it does not have the target, because we are any which ways taking the maximum and we can take any number of times. So if we consider this case, basically even if there is one triplet which is matching this particular target, that will be the answer. We don't really have to take the max. Or if there are multiple, the elements will be at max equal to target or less than that. That's what we have done this, like when we are kind of excluding the max values, that means all the elements will be less than or equal to that. So instead of doing the operation on all the triplets, we are just performing this particular operation which is equivalent to that. So now let's try to run it. Let's submit it. It's successful. Now let's also check the time and space complexity of this. If you see, we are kind of iterating over the triplets, considering the length of triplets as n. Then in this case, it is big of n into 3, because every triplet has 3 elements. So this is big of 1 operation. Again, this is also big of 1 operation because it's just a loop for 3. So overall time complexity of this solution is big of n, and the space complexity of this solution is big of 1, because we are not using any extra space apart from the set, which at max will have 3 elements, because it is storing indices. It will be at max 0, 1 and 2, right? This is the time and space complexity of the solution. I hope the solution is clear. Thank you.